Sam and Peter are among 6 men who are seated at random in a row. What is the probability that exactly 2 men are seated between them? If there are no restrictions on where Sam or Peter can sit, the total number of ways in which they can sit can be calculated in the following way. Sam can sit in any one of the 6 places. Once Sam has taken a seat, Peter can take any one of the remaining 5 places. So, the total number of ways in which Sam and Peter can sit is 6 into 5, that is equal to 30. However, if there have to be 2 men between Sam and Peter or Peter and Sam, the following 6 arrangements are possible. In the following arrangements, Sam means S and P means Peter. So arrangement 1 is S dash dash P dash dash, where the 4 empty dash positions can be filled up with other people. Similarly, arrangement 2 is Sam is in the second position, Peter is in the fifth position. In arrangement number 3, Sam is in the third position, Peter is in the fifth position. In fourth arrangement, Peter is in the first position and Sam is in the fourth position. In the fifth arrangement, Peter is in the second position and Sam is in the fifth position. And in the last or sixth arrangement, Peter is in the third position and Sam is in the sixth position. Note that in all these 6 arrangements, there are 2 gaps between Sam and Peter which are to be filled up by other people. So, there are only 6 possible arrangements when 2 men can sit between Sam and Peter. Therefore, the probability of exactly 2 men sitting between Sam and Peter is 6 divided by 30. Remember, we had found out 30 earlier as the total number of arrangements. So it becomes 6 divided by 30, that is 1 by 5. We have some other comments to make about this question, but before going any further, please like, subscribe, share, and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. In solving this problem, we have not differentiated amongst the 4 men out of 6 besides Sam and Peter. That is, if the 4 men are marked x1, x2, x3 and x4, we have treated all of them as of one type. For example, the 2 arrangements S x1, x2, p, x3, f, x4 and S x2, x3, p, x4, x1 are taken as one arrangement. Remember, x1 and x2 are here, but here it is x2 and x3. However, we have differentiated between Sam and Peter. Thus, S, X, X, P, X, X and P, X, X, S, X, X are considered to be 2 separate arrangements. This has not been clearly specified in the question. If it doesn't matter when any 2 men are sitting between Sam and Peter or Peter and Sam, then the number of possible arrangements will be 6 by 2, that is 3. then the required possibility or required probability will be 3 by 30, that is 1 by 10 instead of 1 by 5. Going one step further, if we do not differentiate between Sam and Peter, the total number of ways they can sit in 6 available seats will be 30 divided by 2, that is 15. If we ignore the condition that the two other men have to sit between them. In such a case, the required probability will be 3 by 15 or 1 by 5 again. Therefore, the question needs to be more specific to avoid ambiguity of different answers. Thank you.